Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome again to another NL Math Man Math Help stream. We're here on a nice Tuesday, a Cinco de Mayo, right? Ketchup floats, but Cinco de Mayo, right? That was the best pun I could come up with, to be honest. In the past 30 seconds, I've been racking my brain thinking of a good Cinco de Mayo pun. So it's as good as we're getting. It's as good as we're getting today. Um, Yeah, welcome back for another math help stream. Today, I'm going to be doing a little bit of a general intro first, just talking about how we submit the coursework in math. We've got still got some new students joining us most Mondays. I think 2 Mondays ago, not last Monday, but the one previous. I believe I had an intro as well. Um, I can't remember. I can't remember exactly what day it was, but I've already had one sort of brief distance teaching intro on stream, and I'm just going to really quickly go over the process there. Right? I'm going to get into Math 3102C, just briefly introduce that course and sort of what the first topics are about. I'm going to recap a little bit on graphing linear equations. Then I'm going to do an intro to inductive reasoning. Now, inductive reasoning is a topic that looks a lot more difficult than it is, which is something that I say constantly in my math teaching. But it's legitimately true. It is. It looks way harder than it is. It's actually a fairly simple topic. Just the way it's phrased might lead you to believe that you should be actually doing more than you are, right? But anyway, we'll get to that there now in a few minutes. First, I did want to talk about winter is raising its ugly head again. Oh my goodness. This scene over here with the two doggies jogging. Two doggies running very get their zoomies. That's not current. That's several years old, judging by Flurry and the lack of sort of brown lines in her eyes. Right. This is probably 3 years ago at least. But yeah, there's snow. There's a fair bit of snow on the ground now in Gander again. Apparently it was almost gone and then it came back. So this is Newfoundland for you, right? We've got Winter 2 Precipitation Boogaloo. Uh, yeah, I mean, I guess Dwight Ball crawled out of his hole and saw his shadow. I don't know. I don't know how that goes exactly. I guess I'm insinuating that he's a groundhog. But he's a little bit late though, right? Because like Groundhog Day is in February, according to Bill Murray, right? But this is instead of the 2nd of February, it's the 5th of May. But it's Newfoundland for you, right? We could at any point in May we could end up with another several months of winter. But I mean, it's traditional, right? Like there has to be. Oh, that's what it is. That's what it is. Twitch chat. I just figured it out. I figured this out live. Like only just Friday, I was talking about how we might, May 2 4. Maybe it's on again. Maybe the double bubble will be expanded and the restrictions reduced a little bit. And we'll be able to get out and go to the cabin again for May 2 4. But that's the thing, right? I think it's a legal requirement. I don't know how it could be legal, but it's legitimately a legal requirement for there to be snow on the 24th of May weekend, Victoria Day holiday. There has to be snow on the ground, or it doesn't count, right? So that's what it is. That's what's going on. We're getting our, you know, we're, we're getting our May dump of snow here. Anyway, St. John's is not, but thankfully. But parts of the island are getting dumped back under wintry weather. It's funny. You get up in the morning and you think, right, like, ooh, is the school going to be open today? There was one day. There was one day during distance teaching where I think school would have closed. But hey, it's all distance now, right? We're closed every day. Anyway, I'm going to just bounce over and talk about a bit of a distance teaching intro. In order to discuss the intro, I'm going to bring up the study guide for um, Math 3102C because a student who is just starting now is only has this one math course to do with me. But I would still like to go over basically how you read the guide and then what you're going to be doing, what you're going to be putting on paper, and what you're going to be sending to me, right? So Oh my God. Pretend I can write. Like, oh my Lord, that was scuffed. Trying to write the word teaching. What am I doing? Okay. So distance teaching intro. Um, we'll call this math distance teaching intro because this is specifically for the math because the first thing I'm going to say, point one, is that um, math notes are not required during distance teaching, right? For level three specifically. But the student who's starting today, or the student who started yesterday, um, is only doing one level three course. But just in case anyone else is watching this and thinks, now's the time for me to rules lawyer my way out of doing some work. That's just for the level three courses. Level two courses, because they're entirely notes, they still have the notes required. Um, however, however, notes are very good practice, and you are encouraged to complete them. So please do still complete the notes. You just don't have to submit them to me for marks or anything like that. Okay. And one of the good things about doing the notes is that on stream here, I can answer any of the questions from the notes that you have. Sometimes if you give me a question from an assignment, I'm not going to answer it entirely because the assignments need to be submitted for marks. Whereas since the notes are not being submitted for marks, you ask me a question for the notes, I'll walk you through every last bit of it, right? So it is still good to do those to be able to understand the material that you're doing, but you don't need to submit them to me. Okay. So assignments are required. I want you to take pics of them, pictures with your phone, and email them to me. So to scroll down over here on the side, right over here, I've got the guide here, right? So just to show you how it breaks down, you see that there's written notes, 10%. Like I said, we're waiving that for now. So the course will be marked at a 90. Really what I do is I make the assignments worth a bit more. You don't really want tests to be worth more. Tests being worth 35% of the course each is already like, that's a massive chunk, right? So instead of this 10% here, each assignment is 15 instead of 10, right? To help pad it out a little bit. But you can get those marks back and buffer yourself a little bit more by doing the review sheets. Now, I'll talk you through what those are here now in a second as well. If you notice as you go down through, right, I just scrolled past a lot of it here, but these are the notes. So this is the part I'm talking about, and I'll go over the first topic out of these today. But what this shows is some questions like you would be expected to do in the course, some of the working, and then talks you down through them, and then gives you questions like these ones here to do out of the book. And like I said, I'll go over a few of those today. But these are the ones that you're not required to submit. I know it says required work, right? But that's because this was before distance teaching. It's the same guide. What is required for you to do still and to submit to me and to get the marks on is, well, we do need the term sheet, right? So there's that one. But then also this here, this unit one assignment. All right, so this is what you're going to be doing, taking pictures of and then sending to me. You can either print it out yourself if you've got a printer, or you can just put down like, write down, say, assignment, write down like assignment one and then question one, and then just go ahead and, answer your question however you want to, right? I'll just put this over here as an aside. That's just kind of what you're going to do, right? You just write it on paper, assignment one, and then, math 3102C. Right, I kind of crammed that in there. Don't worry about that. Right? As long as I can read it. That's the main part. Make sure that you've got a fair bit of lights on in your house. Like I've got I've got a ridiculous number of lights on here now, which is why I'm so illuminated, right? Although I do have this shadow down here. You'll notice because I don't have a box light below me like a professional, right? I've just got lamps alongside on either side. They are on either side. They are perpendicular, right? Which they're supposed to be. But I I ain't quite got the professional setup. This is all just like jury rigged out of things I had in my house. Anyway, um, yeah, so have a lot of light on when you take pictures of your assignment and whatever. After you submit this assignment over here, like the full thing, all of this, and for this course, yeah, printing it will save you a fair bit of work here because this is a graphing course, as you see here. So if you were to draw it out yourself, you would have quite a bit of work to get these drawn out accurately. Um, yeah, printing is the best way to do it. If you don't have a way to print it off, you can always let me know, and I can see what we can do to work around that. Once you finish this assignment, I then send you a review sheet. Now, if you notice, I'm just scrolling randomly, around a PDF, whatever. You see here it says ask instructor for review sheet number 1, right? So we're still following this sort of progression here. Just now what I'm doing is those review sheets are for marks, right? They're optional, but they're for marks. So number 3 is get review sheet. Review sheet. Hey, Slayer Darth, welcome back. No. It's Math Man. There we go. Great. That's good. I like it. I like classic Batman. That's good. Right? Get a math symbol to like zoom into the screen and zoom out. Hey, I should get on that. That'd be a good scene transition, right? Just have like some sort of, I don't know, symbol shaped like the island of Newfoundland with some math over it, and then just have it like zoom out, zoom into the camera, and zoom out as my scene transition. Oh, there we go. I should get some AV people on that one. That'd be fun. So we'll get the review sheet and submit for extra marks, right? Please do that. You don't have to. It's optional, but highly recommended. All right, and then number 4. Okay. Number 4 is complete the unit test, and do please see the intro email for the procedure. I've sent you that one yesterday, I believe. It does outline how we're maintaining sort of testing integrity here during distance teaching, right? So there's a time limit involved, and there's that's basically it, really. I just you had to schedule it to do it on either Tuesdays or Thursdays. Then I send it out to you at a predetermined time, and you send it back to me at a predetermined time. It's not that hard. It's just a way of showing that we are still accountable for keeping our tests, fair and keeping integrity and all that, right? Been reading personal finance and banking books. Pretty sure the economic uncertainty from COVID-19 has obliterated my workplace pension. Yeesh. Yeah, that could happen. I haven't got a workplace pension myself, as lots of people my age don't. But I do have a private pension. Trying to read about pension laws to figure out how best to invest in or manage your pension. Yeah, I mean that's the thing about like for in Canada, right? Our RRSPs are a common sort of private retirement savings fund. You know, for most people, I mean, you just put it in February, right? You just put it in so that you get the tax break that year. Save up as much as you can and put it in. And there's not a whole lot more you can do, to my understanding, other than you know understand how long you want the money to be in for, and then pick an appropriate amount of risk, right? Like I'm in what I've got put in is in medium risk, they say, just because I know that I'm not going to be needing to take it out for a long time. It does mean that the money that I put in took an awfully big hit um, with the market tanking early on in COVID-19. But it's yeah, stock markets are a weird thing, right, for this kind of situation because like the stock market is not the economy, is at all. Like listen to like Paul Krugman or somebody talk about that, right? The stock market is not the economy. But yeah, I don't know. Like put in money when the market is low if you got it. That's the best way to do it. Like the market was depressed a lot more than it is currently a few months ago, right? So that was the time. That was the time to put money in, right? Because it's all about the percentage of the market that you're controlling, kind of. And of course, it's a tiny, tiny, tiny percent. But when you see the amount of money that you have in an RSP or in a retirement fund shrink, it's because of a contraction of the market. It's not because you're losing money per se. It's because everybody is losing. Everybody has the whole market is worth less, so the percentage that you control is worth less as well, right? But you're still controlling the same percentage of the market, sort of. So when the market rebounds, you're going to see your pension rebound as well. Yeah, the economy is the goods and services we produce. The stock market is how much investors are willing to pay for output or companies. That's yeah, sure. That's a good way of looking at it. But of course, stock market is also on sort of on futures, right, as well, which is a sort of a tumultuous thing to try to keep a handle on. But I mean, it all depends on where you are as an investor, I suppose. Me, I'm pretty basic. I'm just like putting money into RSP to reduce my overall tax burden for the year. So, you know. Anyway, uh, finance is relatively interesting. It is kind of math related, but I did want to carry on here with this stuff. That's a great topic, though. I do like talking about that for sure. But anyway, so Clarence, I think, the new student for these ones. This is basically just the breakdown of how you're going to do these ones, right? So this is the way that we're going to do each of these units. And I think you've got where you just have the one course to do. Oh no, no worries, Slayer Dareth. No, don't be sorry. I like the interaction for sure. But I am going to let's see. Yeah, I'm going to mention the first of these topics, just briefly show you what's in the book as well, right? So this is going to be a Math 3102C Unit 1. Oh, I'm up a little bit high. There we go. So first up, page 270. Read page 270, complete pages 272 to 274. So let me see here. Here we go. Yeah. So I'm going to zoom in a little bit so we can see these a touch better. List the corresponding angles and corresponding sides for PQR and TUV. Right? So all these questions are asking us to do is basically to say what side of the triangle compares to what other side of the triangle. Let's zip back over to this different display so we can see a little bit clearer what we're dealing with here. But, right, so question 1. This is fairly basic, just the way we would start approaching these separate questions, right? So we could say, angle P corresponds to angle T, right? We could say side, say PQ corresponds to TU, side TU, they're like that, right? It's, all we're saying for those, well, what does corresponding angles mean, right? Corresponding angles are equal, and corresponding sides have the same ratio. Corresponding sides have the same ratio. What does that mean? Well, I think I can better show what that means by doing question 2. Right? So we scroll down here. It says check if each pair of shapes has proportional corresponding sides. Excellent. Okay, so let's see. So number 2A here, right? So our two shapes, I'm just going to draw them out really briefly on my paper here. Now the notes that you submit, or the assignment rather questions that you submit, you don't necessarily need to draw out absolutely everything for the questions, but I do encourage you to do that because I do find that personally, at least for myself, drawing out a diagram of a question really helps to sort of illuminate what the actual question is asking, right? So here now, those are roughly drawn, but that's fine. Let's see, this is 15. No units given. That's odd. 13, 13, and 10. This is 3, 3.2, 3.2, and 2. Okay? So, and this is, let's see, this is S, R, T, U. This is W, V, X, and Y. Right? So now, if these shapes are similar, their corresponding sides will have the same ratio, right? So corresponding sides here, say SR corresponds to WV. So if there would be SR, side SR, divided by side WV would equal side ST divided by side WX, and so on, right? Which would equal side, say, TU divided by side XY, and so on, right? What's important is that we always have the same shape on the top and the same shape on the bottom. I put the big shape on the top and the small shape on the bottom. That's just what I chose. But it's important to have the same shape on the top and the bottom in each ratio. All right? So now I'm going to go through and just sort of calculate these out, see if this is true. Right? So now I'm going to go say SR over WV. That's going to be 15 over 3, which is going to be 5. Okay, good. Now we're going to try ST over WX, right? So ST is 13, WX is 3.2. Let's try 13 over 3.2. You probably already know that's not going to be the same, right? Because it's a smaller number divided by a bigger number. Obviously, that's going to be a different answer. So we get 4.06. So it's approximately 4.06, right? And I'm just going to, we already know that they're not, right? That they're not proportional. But I'm just going to go through and do out the rest of these that I wrote up here. TU over XY is going to equal 10 over 2, which does equal 5. All right, so these ones have the same ratio between their sides, but these ones don't, right? So I can say SR over WV does not equal ST over WX. Therefore, it's the symbol for therefore. Therefore, these shapes are not similar, right? So again, like I said, like the way that we would know these shapes are similar is if this divided by this is the same as this divided by this is the same as this divided by this. And here, because the sides do not equal out to be the same, we know that these shapes are not similar, right? Let's go ahead and I'll do 2B as well. Do that one down here below, maybe with a little bit less deliberation beforehand. But for 2B, we've got two triangles. Now, try to resist the temptation to judge these based on how the triangles are written, right? But how the triangles are drawn, rather. So I'm just going to use the same stencil here for both triangles. Because teachers are sneaky, and sometimes the way the diagram is drawn, like down here for 2B, sometimes that diagram doesn't really have a whole lot to do with what the numbers on it are, right? Sometimes. Sometimes we're sneaky like that. But we have a 4.6, a 5, and a 2, and this is X, Y, and Z. And then we have a 2, a 3.1, and a 2.4, and this is L, M, N. Right? So I'm just going to go ahead and start doing some of these. So XY divided by LM is equal to 2 over 2, which is equal to 1. Right? So right from the start, we can see that these are not similar because these sides are the same, but these ones aren't. And if one pair is the same and the other pairs aren't, obviously they're not similar, are they? But I'm just going to go ahead and show some other ones, right? So YZ over MN is going to equal 4.6 over 2.4, which is going to be, what is that, almost 2? 1.92. Right? And already we can see that they don't equal. So just one example of two sides where the ratios are not equal is enough, and we can stop. Right? So here I can say that side xy over side lm does not equal side yz over side mn. Therefore, the shapes are not similar. Right? It's fairly straightforward. Let me bounce back over to a different display here so we can see the page a little bigger. Let me zoom out a little bit. See, this is where I need that NL Mathman symbol. Right? That'd be good. That'd be great. Check if each pair of shapes is proportional corresponding sides. Did it? They don't. Use a ruler to check if a pair of shapes is proportional corresponding sides. Oh, that's a bad example. We usually say use rules, not rulers, right? Because we're out to get you. We're not gonna let you just measure things most of the time. Occasionally you can. Use a protractor to check whether each pair of shapes is equal corresponding angles and state the angle measures. Yeah, I'm going to skip those for now. I won't be doing the protractory stuff. I think this is probably a decent example of the way that we would start off, though, with these questions. So, yeah, I think Clarence, that's probably a good brief intro. You haven't asked any questions yet specifically about the material, so I think that, excuse me, just going over a brief intro of how you would do it and how you would submit your work and the testing procedure and all that is probably beneficial. I hope that helped you. Yeah, if you're seeing it live, welcome. And if you're watching in the future after I've linked you the video, welcome, future Clarence. This is past Peter. Hope that was useful for you. Now, let me bounce back over to my intro screen. Stream starting soon. Nope, it's already going, so get rid of that. Next up, we're going to do, yes, graphing linear equations recap. Right, okay. So I had a student just finish a unit on those, so I'm going to recap just a few little teachable moments that I saw from the activities that they did. So let me skip back over here to my document display. There we go. This now is Math 1101C recap. Just real briefly. Now, some of these questions, I've only got a few to do here. They're going to be fairly quick, and then I'm going to get on to introducing the next unit in line after this one. Okay, but I'm going to do question 3 here first. So what is the slope of a line perpendicular to the line graphed on the grid? Well, first up, we got to remember that perpendicular lines have negative reciprocal slopes. Right? So what you do, you just flip it. You take it as a fraction, you know, you twist it, turn it, bop it, pull it and pass it. You just flip it, and then you put a negative in there. That was pulled from way back. Bop it. Remember that? Man, I feel like I feel I feel like a real hack comedian up here, aren't I? I was like, remember those? How about Decepticons? Remember those? Okay, there's a Metalocalypse bit. Anyway, so here's the graph that we've got. Now, how are we going to find the slope of this graph? Now, remember, we're just going to get to any point, any clear point on the graph, then see another clear point on the graph, and then count, right? So this one here, this looks like 0, 1. It clearly crosses there. Where's the next place that it clearly crosses? Over here, I would say. It's definitely crossing there, right next to the index finger on my pointer. So what's the rise over run for that? That's all we need, right? Because slope. Now we could do the delta y over delta x. Could write that out, right? But for here, for right now, I'm just going to count, right? So the rise from here to here is a rise of 2. And what's the run? The run is 5, right? So the negative reciprocal, that symbol means perpendicular. Negative 5 over 2, right? You just flip it. You got to flip it and then make it negative. That's all we're doing. All right, so the answer there is going to be A, negative 5 over 2. Option A. Okay, next one I wanted to do. Like I said, these are going to go fairly quick because they're just smaller questions. Number 6 here. Gonna scroll down a touch. Some nice mouse noises on my stream. Mouse noises and mouth noises. That's what I specialize in. What is the slope of the line passing through the points A, -7, -6, 7, and B, -6, -7? Now remember, when in doubt, graph it out, right? That's my first suggestion. But let's do the delta y over delta x and see what the heck happens here, right? So we know that slope equals rise over run, right? Which is delta y over delta x, change in y over change in x, y2 minus y1 over x2 minus x1. I know I write this out every single time and you're getting bored of seeing it. But the reason I do that is because, it's rote, man. That's how you memorize things. You don't remember stuff. At least I don't. I don't remember anything without copying it down over and over and over again. Right? So, now normally I say we look at it, we pick the leftmost point. We pick the point with the smallest x coordinate to be the first point, and the point with the largest x coordinate to be the second point, right? That's just the way we do it. But if we look at these, we already start to see our problem, don't we? The x coordinate is the same. If the x coordinate is the same, we already know it fails the vertical line test. We already know it's got an undefined slope. But hey, whatever. Let's go through and let's write these out, right? So y2, I'm just going to pick the second point that I'm given to be 0.2. So y2 is going to be -7, right? And then y1 is going to be +7. And then x2 is going to be -6. x1 is going to be -6. Oh boy, so that's -14 over 0. And we can't divide by 0, so it's undefined. Right? And there's one reason why writing it out like this can be pretty helpful. Because if you were to take this and graph it, well, you would probably notice that what's going on is a vertical line, right? Because we're going to go, our first point is going to be -6. 1, 2, 3, 4, 5, 6. -6, 7. Really, really, really rough graphing of it here, but it's just to show, to make a point, right? So there's the first one, then -7. There's our second point. We join those guys up. It's a vertical line. Vertical lines have undefined slope. Or slope is undefined. Okay? So there's the main reason I wanted to show this one is because this is an edge case, and like teachers love trying to trip people up with edge cases, right? That's sort of our bread and butter. When you're dividing by 0, that don't work, right? And you can think back to what division means, right? Division means how many of this number can we get out of this number? And how many sets of size 0 can we get out of a set of negative 14? Well, already the negative do sort of throw a monkey wrench into the way this works, but, you know, imagine it was positive 14, right? How many sets of 0 can you get out of it? Well, infinitely many, right? It's an undefined number. I'm going to go bounce on down now to question 18. Question 18 on this sheet. Okay, so this one here doesn't really need anything drawn out. The principal compares the cost of 2 photographers for student IDs. Which statement is true? Now I have to zoom out a little bit because the aspect ratios of my documents are not cooperating very well. So we say clickster is the blue line, and then snapshot is the black line. So which of these statements is true? Well, this is sort of like a test taking skills thing all of a sudden here now. We got to go down, we got to eliminate some of these ones, right? So click-through is a better value for less than 100 students. Less than 100 students, well, 100 is over here. Is click-through the better value for less than 100? Well, it looks like it's a lower cost down here, but up here it's higher. So no, that's not true. Because it changes. It changes partway through 100, right? Clickster is a better value for more than 150 students. We've got no way of telling that. Like the maximum number of students we even see down here is 100. Oh, my cursor's not coming through, is it? My cursor is not coming through. Okay, right. So for less than 100, well, like I said, everything on here is less than 100. Sometimes Clickster is more expensive in this section. Sometimes it's less expensive. So we know A is not the answer. B then, Clickster is a better value for more than 150. Well, we don't have more than 150 on here, so we know B is not the answer. Snapshot is the better value for less than 100 students. Well, for less than 100, snapshot is better when it's between 50 and 100, but when it's between 0 and 50, we see suddenly that snapshot actually is more expensive. So snapshot is the better value for more than 50 students. That part is true, right? Because once you get to 50 students, snapshot is cheaper. So all it is just asking you basically which one is going to be cheaper afterwards. So question 18 has to be option D. Right? That's all there is to that one. Excuse me. Really tearing through this one here now. Right, back over to my intro. Oh, we have some zoomies here in the intro. They're probably out running around like that today now in all the fresh snow. Right, there's always brother's always got to try to be out in front. He can only do it because Sissy's leg is bad, right? Because she hurt her leg. If she was still spry, she'd be giving him a run for his money. Although he is quite fast. Smokey is. He can put some speed down when he wants to. He loves running alongside the skidoo. Like when you're out driving around a skidoo, he loves being over there. Just he won't get on the skidoo. He'll actually get super excited in order to get off and just run and try to keep up with you, which is pretty fun. So Math 2101A, Intro to Inductive Reasoning. Gonna do a little bit on that one. Let's see here. Okay, so this unit is quite a bit different than some of the other ones that you will have seen so far, which is one reason that I want to point this one out specifically. Now, Betty Ann, you did mention that you're on to the assignment already, which is great. Oh, I'm glad that you have understood it from the textbook. That's great. All right, it is one of the issues with this program in general, of course, that these textbooks were not necessarily made to be sort of teach yourself textbooks. These were textbooks that were made to have a teacher there to give lectures and to talk along with them, right? That's why they have teachers' guides and all this kind of stuff. They're not necessarily made as a comprehensive all-in-one or resource for teaching yourself. Now, with our guides that we package along with them, it's quite a lot better, and you've got quite a lot more resources to use on your own. But I still just want to work down through and mention a few of the initial questions, even though you've gotten past those, just so you'll know the general thing that we're looking for, because these questions are quite a bit different than your normal ones, right? So making conjectures or inductive reasoning. Make conjectures by observing patterns and identifying properties and justify the reasoning. Explain why inductive reasoning may lead to a false conjecture. Well, how about we go over to the book? And oh, that's the wrong book. We go over to the, here we go. Right. So this is the book. This is the first page that you will be looking at in this unit. And I want to just sort of walk down through this example and show kind of what inductive reasoning is here. We see it over in the corner, right? Inductive reasoning is drawing a general conclusion by observing patterns and identifying properties in specific examples. Right? So we're going to be over here on this investigate. So this is math 2101A. And this is unit 1. And this is going to be page, what is this, page 8? Page 8 of the textbook? Page 6. Page 6 even. Okay, so organize the information about the pattern in a table like the one below. Well, what do we got going on? We've got a pattern here where we start off with one triangle, then we go to the next triangle, then we go to the third triangle. So these are what we call triangular numbers. Now, you don't see these, for whatever reason, like I went through the North American school system in high school, well, not North American, obviously, because there isn't, there's to the tune of like 62 in North America, well, even just in US and Canada. Anyway. 63? 63. 64, I guess, if we count Alaska. 65 if we count Hawaii. Don't know how many are in Mexico. It's Cinco de Mayo. I should know some stuff about Mexico today, right? Like today of any day. Anyway, these are the triangular numbers, 1, 4, and then 1, 4, 9, and so on. But what you'll notice about the triangular numbers is you're actually adding sequential odd numbers to the previous number, right? So for example here, in A, we see that we have figure on top and then number of triangles there below, right? So I'm going to do it vertically instead of horizontally because it's a lot easier to write this out, right? Number of triangles. So figure 1 has 1 triangle. Figure 2 has 4 triangles. Figure 3, as we can see from counting it there, has 9 triangles. Right? Now, you see the difference here. This is actually something that we're not on to this yet, but we will get onto this eventually. And it's called the order difference. So this is going to be the first order difference. I'm going to write this out over here just so you can see. The first order difference is sort of subtracting these two guys from each other. So this one here goes up by 3. This goes up by 5, right? In the next one, the fourth one, it's actually going to go up by 7. So we're going to have now 16. 5, right? This is now going to go up. You might be maybe seeing this one. This is going to go up by 9. This is going to become 25. Let me just show you here. Oh boy, I'm disappearing. Ah! Right, yes, they are skipping quite a few of the triangular numbers, of course, yes. Anyway, yeah, so what we're doing here, we see in the first shape we've got 1, then we add 3, then we add 5 to make another row, and then the next one we're going to add 7, then we're going to add 9, and it's going to be so on. Right, so the first order difference is going to be here, going to be these ones. The second order difference, 2, 2, 2, right? So you have to go to a second order difference before we're actually getting something that is a constant difference between them. right? So with a partner, discuss what you notice about the data in the table. Well, that's what I'm saying here, right? These are going up. This goes up by 3. This goes up by 5. This goes up by 7. This goes up by 9, right? Which means each time the amount that it's going up by is increasing by 2. So then, with a partner, discuss what you should notice about the data in the table. So we've kind of done that. Extend the pattern for 2 more figures. We've done that. What numeric pattern do you see in the table? We've done that as well. All right. So now we can go on to this next part. Is George's conjecture reasonable? So she says, I think figure 10 in this pattern will have 100 triangles. All these triangles will be congruent to the triangle in figure 1. Well, they're definitely all going to be congruent, right? Because you notice that every time we're going up here, it's becoming a new equilateral triangle, right? Is the next one going to have figure 10 going to have 100? Well, let's find out. Let's find out. So this is now going to go up by 11. We know, so that's going to become 36, right? 7 is going to go up here now by 13, and it's going to become 49. Are you noticing anything yet, Twitch chat? You notice anything about these numbers? You probably are. I hope you are. 9. This is going to go up by 17. This is going to become, guess what? It's 81. Oh, how could you guess? And this is going to go up by 19. And it's going to become 100, right? And your second order difference is still going to be 2 each time. Isn't that cool? So what we actually have, these are quite clearly, it's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. Right? So those are just going to be the numbers squared. So how did Georgia use inductive reasoning to develop her conjecture? Well, she saw that in the first one here, yeah, I was wrong. These are not the triangular numbers. I don't know why I mentioned that first. It looked like it was going to be, but then it wasn't. Sorry. But yeah, these are all the square numbers, right? So figure 1 is one object. Figure 2 is 4 objects. Figure 3, 9 objects. 16, 25, 36, 49, 64, 81, 100. So is there a different conjecture you could make based upon the pattern you see? Explain. Well, sure. Sure, the thing, kind of the point that I'm trying to get at here, or I would like to get at in introducing this unit, is that there's plenty of different conjectures you can make. Just because one is listed in the back of the book as being a conjecture you could make, it doesn't mean that that's the only one that you can make. There's plenty of different things that you could say that would be true about this scenario. Like if you said, instead of saying that all these numbers are the numbers squared, if you said that they are increasing, like I said first, if they are increasing by another 2 each time, right? This increases by 3, then by 5, then by 7, then by 9. That's another conjecture that you're making, right? And that's also a true conjecture. Or if you're saying that the rate, sort of the amount that it changes by, is increasing by 2 each time. Like over here, the second order difference is 2. That's another true conjecture, right? Anything that works out to be true for all the cases is going to be a true conjecture for these, right? Sometimes that makes the math a little bit more confusing because it does mean that there's a whole bunch of different things that you could say that would be right. But in a sense, it means that it's a lot easier because all you have to do is be able to tell me something that is going to work out and you'll get the marks for it. Let me show you an example then by doing one of the questions from the notes. Page 12 over here. Say Troy works at a ski shop in Whistler, British Columbia, where the type of downhill skis are available: parabolic, twin tip, and powder. The manager of the store has ordered 100 pairs of each type in various lengths for the upcoming ski season. What conjecture did the manager make? Explain. Like, it's not even a math question. This is a business question. Now, this is getting back to the investment stuff we were talking about earlier. This is about how you predict the future needs of your company, right? Like, the manager, obviously the conjecture is that all the different types of skis are going to be equally popular, right? Simple. He ordered 100 pairs of each type. in various lengths for the upcoming ski season. The conjecture he made, yeah, is that he also, you could reasonably say, that he made the conjecture that all skiers, no matter what sort of age or what sort of skill level they are all going to want these different types of skis, right? Like imagine, say, the smallest skis, like the child-size skis. This guy's assuming that children are going to be using parabolic twin tip and powder skis as much as adults are. Right? You could say that's another conjecture that he's making. It's just the only thing I'm going to be thinking about when I'm marking these questions is, does the conjecture that you're making make sense based on the information you've been given? But how about we look at one that's a little bit more mathy? So, see, Thomas gathered the following evidence to notice the pattern. 17 times 11 is 187. 41 times 11, blah, blah, blah. Thomas made this conjecture. When you multiply a two-digit number by 11, the first and last digits of the product are the digits of the original number. Is Thomas's conjecture reasonable? Develop evidence to test his conjecture and determine whether it is reasonable. So the only thing you got to do to prove one of these wrong is basically to have one example that contradicts this, right? First and last digits of the product are the digits of the original number. Okay, so like I said, all we've got to do to prove one of these guys wrong is to show one example where it doesn't work out, right? Oh, what I put that to page 12. Page 12. And this is going to be question 2. Right? Develop evidence to test his conjecture and determine whether it's reasonable. Let's just try a few two-digit numbers, hey? Let's just do that. I'm going to try, let's say, 22 times 11. Let's try 34 times 11. Let's try 51 times 11. Let's try 99 times 11. Let's see. Let's just pick some numbers that they didn't and see if those work out, right? Because all you got to do to prove a conjecture wrong is show one example where it doesn't work. All right, so 22 times 11, that's 242. That checks out. Conjecture seems okay so far. 34 times 11, 374. Hey, that checks out. 51 times 11, 561. That one checks out. 99 times 11, 1089. Wrong. Doesn't work. It's not actually true. It's true some of the time, right? But we can see from this one, Troy made the conjecture when you multiply a two-digit number by 11, the first and last digits of the product are the digits of the original number. Are they? Are they here? Is the first digit a 9? No, it ain't. Right? So that means, right? Same thing. Say we did 88. 88 times 11. Don't work. 77 times 11. Don't work. 66 times 11. Don't work. Right? So there's quite a few. There's quite a few that you could pick that don't work out. But either way, you get one that doesn't work out, you're good. Right? Practicing. Make a conjecture about the sum of two even integers. Develop evidence to test your conjecture. Okay? This is one that I would like to walk down through. It's question 3 here, because question 3 shows a bit of notation that we are going to be seeing pretty regularly in these courses here, right? So two even integers. Well, a conjecture that I would make is that the sum of two even integers is an even number, right? Sum of two even integers is also even, right? Now here is something. Now, Betty Ann, hopefully you're watching this at some point, because this is something that's going to be really important in your tests and your assignments and all that is knowing how to write out certain sort of math properties in algebraic terms, right? So we know that the way we represent an even number is 2x. Because the definition of an even number is a number that is divisible by 2, right? So the way that we write out an even number is 2x. Because no matter what x is, 2x is even. If x is 0, 2x is 0. 0 is an even number, right? X is 1, you know, or we could say xei, where x is an integer, right? That is important to factor in there. We haven't done set notation yet, I don't believe, but it's super important to get that in there, right? Because if x is 0.5, obviously that throws a monkey wrench into it because 2 times 0.5 is 1 and 0.5 is odd and 1 is odd, right? But it's x has to be an integer. Okay, so the sum of two even integers, so I could call that 2x plus, I could say another 2x, but I don't want to necessarily add the same even integer, but I want to add another one, plus 2x, I could even say plus 2y, say. Yeah. Right? Equals, well, that's just going to be 2x plus 2y, but I could call that 2 outside of x plus y, which, 2x plus y is divisible by 2. It has to be because the 2 is outside. Therefore, it is even. I know this might look a bit odd, right? But this is all you really got to do to figure out these questions. 2x represents an even number, and 2y and so on. So if you have an even number here plus an even number here, that makes 2x plus 2y, or 2 outside of x plus y. 2 outside of x plus y is divisible by 2, therefore is even. Right? But making conjectures is a bit of um, an odd twist. But thankfully, it's really just it's a little bit of a conceptual twist. But the actual math that you're doing in this unit is relatively easy, and I think fairly approachable. Okay, so I hope that was a reasonable introduction to what you'll be doing. Right. If you got any questions, please do let me know. But I think that we're getting toward the end of what I had to do for today. Um, yeah, we've covered these 3 topics here, or 4 topics, but I mean the intro isn't really a topic. Okay, I hope that was useful for everybody. Yeah, thanks for. Oh, I'm watching. Me is here. Oh, thanks, me. Thanks for being there, me. Uh, hope that was useful for you. If you have any questions about, say, the assignment or anything specific, you can drop it into chat. I don't know now, I guess. If not, yeah, I think that'll probably be a good amount to cover for today. So yeah, instead of just sitting here with dead air, I guess yeah, it'll be another math stream down. Thanks for joining me. Hope it's been useful for you. And anyone watching this on recorded versions, hope it's useful for you as well. It's yeah, just as valuable for people to be watching it after the fact. I didn't these streams are not mandatory, of course, right? There's nothing mandatory about coming and watching these live or interacting with me on stream or anything like that. I do appreciate it because it does make what I'm doing a lot easier and a lot more enjoyable for people to be on, letting me know of other questions that you need to work on. But anyone who watches this in the future, I'm glad that it's useful for you as well. Um, yeah, every bit as important for people to be watching it on recorded video as live. Okay, thanks for being here, and have a great rest of your day, and stay safe.